Hello dear students, let's start law of conservation of mass. Now this topic is belong from the chapter 1 of class 8 in subject chemistry. Now the law of conservation of mass. This law states that mass can neither be created nor destroyed. That means the total mass remain conserved in any physical or chemical change. Now in the last class we have already studied that some physical changes and chemical changes occurs in the nature. So in any changes, the total mass of the reactant and product are remain conserved. That means the total mass of the reactant remains equal to the total mass of the product. It means the mass can neither be created nor destroyed. As for example, if you can take 10 gram of the ice cube and heating the ice cube, then ice cube become melting, and after melting ice converted into the liquid water. The mass of the liquid water should also 10 gram. You can find that 10 gram ice when melt, then we obtained 10 gram of the water. That means the mass of the reactant and the product remain unchanged, remain same. Now it can be proved by an activity. Now the aim of the activity is to verify the law of conservation of mass. To verify the law of conservation of mass. Now for this activity, for the verification of conservation of mass, we required some materials such as barium chloride solution, sodium sulfate solution, a conical flask, a test tube, a measuring cylinder, a cork, and a weighing balance. Now what is the procedure? How can I proceed it? How can we proceed it? Take 10 milliliter barium chloride solution in the measuring cylinder. Now suppose this one is the measuring cylinder. Measuring cylinder having the mark, and it is made up of a glass, and this mark in milliliter. Suppose that 1 milliliter, 2 milliliter, 3 milliliters. So up to 10 milliliter we can take in the barium chloride solution and pour it into a conical flask. This one is the conical flask. Pour the barium chloride solution in the conical flask. After then, again we take 10 milliliter of sodium sulfate solution also in the measuring cylinder, and after measure of 10 milliliter of the sodium sulfate solution, we can pour it into a test tube and tied up this test tube with a thread and suspended this test tube in the conical flask which having the barium chloride solution, and then put the cork on the mouth of conical flask. After then we can measure the conical flask which having the test tube and after measuring on the weighing balance we can find that 200.22 gram of total weight of this conical flask which contain barium chloride solution and sodium sulfate in test tube. After then, we mixing, lose the threads, slightly open the cork and lose the threads. After losing the threads, the test tube fall into the conical flask, and both the barium chloride solution and sodium sulfates are mixing to each other like this, and shake the conical flask. Shaking the conical flask, that's why both barium chloride and sodium sulfate are mixing to each other. Now the reaction between two reactants will happen here as mentioned. Barium chloride and sodium sulfate both are present in the aqueous form, and both are combined to form the barium sulfate and sodium chloride. After the reactions, so reaction to be happen, then what you will observe? Observation. Again we measure the conical flask on the weighing balance. After measuring, that means after the reaction to be happened, we can measure again the conical flask. Then after measuring, we are found that the weight of the conical flask is 200.22 grams. In this conical flask right now present sodium chloride and barium sulfates. That means the products are present after the reactions, and we conclude that the weight of both reactant 200.22 gram and the weight of the product 200.22 gram both are equal, remain same. So this activity proved that the law of conservation of mass. So conclusion, the law of conservation of mass is verified. Okay, thank you. This chapter is completed. So all of you remember and solve the question answer from the exercise of this chapter.